Now let me introduce to you an additional concept on how we can actually do these warping that actually tries to avoid some of these granularity and aliasing and minification magnification problems, and that is using a mesh on an image and deforming that mesh to generate the warps. To demonstrate this, let me use these two images. We will refer to this as a source and this as a target. Some of you may recognize this person. Actually, these are images from my PhD thesis from many years ago. And the big difference between these two images is one neutral expression, the other one is a small expression. Now we're interested in basically computing the warp between these. Now, one way to compute a warp would be basically finding out a corresponding set of points that are common in between these two. To achieve this, many different methods could be used. I'll talk about one in a second. And basically, once we find this corresponding set of points, we can interpolate between them using a displacement field. So first we want to do is take this image and basically discretize this, or actually represent this as a mesh, which each element is basically a set of triangles. So here I'm basically showing that I can actually now take this, put it on top of this, and this would be rectangles, but what we are interested in is triangles. So each and every one of these squares would actually be two triangles, and you basically kind of see what I mean by this. And now basically I have a region of pixels or values or intensities and stuff like that of an image put on each and every one of these triangles. What we can then do is basically use an affine model to transform each triangle from one to the other. Of course, we also want to generate a similar triangle mesh with the deformations that kind of show all of this. This is my displacement field. Here, if you notice that there is a little bit of asymmetry, the eyes get a little smaller, and this basically showing most of the motion is here and most of the motion is here. You see a lot of deformation. Again, deformation is 3D, but in 2D you can start noticing this is where the changes are. So using this now, actually we can come up with a model of how we would transform a region points from here to get to this. And of course, to achieve this, we will use the affine model for each and every one of the triangles. Then we'll basically use inverse mapping to be able to go from there to here and being able to then generate a warp field. So now you notice basically the interpolation resulted in going from a neutral expression to a small expression. And basically what we did was we created a warp from one to the other. And in this case, of course, I showed you all of the in-between frames to kind of make it look like a person went from neutral to a smile. Again, remember, we did not have any of those frames. They were generated because of the warp field. Let's look at it one more time.